Hi, have you ever wondered why when you hold a slice of pizza, it flops down, but if you fold it, it stays up? Have you wondered why tape measures are shaped like a U? Have you ever driven under an underpass and looked up and seen the beams, and they're always the shape of the capital letter I? Welcome to Brick Stud. Today we're going to use Lego to learn the science of beams.
Brick Stud.
If you've ever built a deck, you may have noticed that if you take a piece of wood, like a 2x4 or a 2x6, and you lay it on its side, it's very flexible and it bends. But if you take it and flip it upright, then it's very rigid and doesn't bend. We're going to look at an example of that right now. Here we're going to make some vertical portions of a structure called columns. Then we're going to take a beam. This is a 2x16 plate. And if you place it flat like this, it's quite flexible and bendy. But if you take it and stick it up on its side like this, it's actually quite strong and it doesn't bend. The property that tells you how much an object will bend is represented by the letter I. It is called the second moment of area, or the area moment of inertia. Frequently, we just reduce this and call it the moment of inertia. This can become confusing because there are two topics now in physics that have the same name, moment of inertia. One covers an object that is spinning, and the other is what we're learning about today, when an object is bending. You can tell the difference between the two subjects by context clues. If you're talking about an object that's spinning, that's a different topic. If you're talking about an object that's bending, then that's this moment of inertia that we're learning about today.
This is the equation to solve for the moment of inertia. We are not going to solve this problem, and we are going to do what engineers do well and look it up in a table. Here are some common shapes and the corresponding equations. If we look at the equation for a rectangle, it is bh cubed divided by 12. B represents the width, h represents the height. You may notice that the height is cubed, which means the height is much more important than the width in determining the moment of inertia. Here is the example of our two Lego bricks. One plate is laid flat and one plate is laid vertical. If we look up the dimensions of Lego bricks, we can plug in and solve the moment of inertia for a flat plate and the plate on its side. The vertical plate has a much larger moment of inertia. In fact, the vertical plate is 24 times less bendy than the horizontal plate. Here are the examples for a 2x4 and a 2x6, comparing their horizontal position and their vertical position. Let's look at the example of the tape measure. To solve for the moment of inertia of the tape measure, you make an imaginary cut along the middle of the tape, then look down the tape measure at that imaginary cut. The imaginary cut would look something like this U shape. You draw a line through the middle of the U shape. To find the moment of inertia, you calculate all of the area that is away from that dashed line. The more area that is away from that dashed line, the higher the moment of inertia. Let's look at the example of the pizza slice. Make an imaginary cut. Look down the end of the pizza at that imaginary cut. The more area and the further the distance from that line, the higher the moment of inertia. Let's look at the steel beam example. make an imaginary cut along the steel beam. Look down at that imaginary cut. Calculate all of the area and the distance from the line, which then creates a very high moment of inertia for a beam.
From our previous lesson, we learned that the height of the beam is the most important part. So more material you can get away from the center. So if you look straight on the end, the taller you can make it, the more material away from the center line, the stiffer it will be. And you don't even need to have material the whole way. So this is actually called a sandwich technique. So you take a plate, a block, and then another plate. You can hook that together, and now we can make this even longer, and it's still pretty strong. We're going to look at some examples. We'll look at the Ninjago City, and we'll also look at the Tower Bridge and see how those have high moment of inertias. Okay, so let's take a look. This is the second floor from the Lego Ninjago City set. So this is the first main structure after the bottom floor, and there's quite a bit to hold up. And then on top of this, you have the department store, you have a little tree and a house, yellow house, and then the roof and the big green tower. So we flipped it up onto its side. If you look underneath the floor, you'll see that there's a whole bunch of Technic pieces that have been hooked together, and then there's plates sandwiching the top and the bottom. So by putting a block and then a plate on the bottom and a plate on the top, that sandwich technique, you're able to make a floor that's strong enough to not bend. So on top of that, you can then build on top. Here's another example on the Tower Bridge. You can see that right here, making a large open rectangle shape, this is a lot stronger, doesn't bend as much, because by making this as tall as possible, getting as much area away from the neutral axis or the bending axis, the stiffer this is, the less likely it wants to bend. So when we're talking about moment of inertia, that's not just for up and down. Let's say on this tower, you can see this tower's a big rectangle. When the wind blows against this tower this way, it's going to try and push the tower over. Because this tower has a big open rectangle shape, it resists forces of pushing the wind over, because this tower is also wanting to bend this way, sideways. The moment of inertia doesn't have to just be for up and down, it could be sideways forces, so wind or earthquakes. Now you know why when you fold pizza in half, it doesn't flop down. Why tape measures have the U shape, and why beams always have that capital I shape. Thank you so much for watching this video. Please like, share, subscribe, comment below. There's also a Patreon link in the description. This is the first episode of Brick Stud. There's so much great content coming out. Something that's showing up in the near future is a lesson on why tall, skinny towers always fall over, and also different airplane shapes, so the science of airplanes. We're also going to be reviewing all of the Ninjago sets that I currently have in preparation of the new Ninjago City Garden set. So I'll be ordering that, but to get ready for it, we're going to review the Ninjago sets. Thank you so much. Till next time, keep building.